Alright, so this is the nitrogen tank. And before we get into writing anything or talking about the procedure for setting up the regulator for the nitrogen, anybody tell me what's in the air? What are we breathing? Right now, what am I breathing? Oxygen. All oxygen though? Is it 100%? No? What do we got? About 20% oxygen, and the rest of it mostly nitrogen, about 79%. You go back to your science classes. Why? What's the deal with oxygen when it's 100%? Very flammable, highly flammable. In fact, we're going to add some oxygen to our acetylene, which is another flammable gas that increases the temperature so that we can raise the melting point of our brazing rod so that we can melt the two pipes together, which is going to be coming very shortly for you guys. But before we do that, you're doing the filter dryer project, which is going to require you to pressure test it in a bucket of water. All right? And in order to do that, you're going to need to set up the nitrogen tank. And this is another check off for the first quarter that we do. You're going to have to set this nitrogen tank up with the regulator. That's what this thing is called. And that's really what it does. Every square inch that you see has about 2,500 pounds of pressure in it when the tank comes to me right off the truck, brand new. All right? And it's not a brand new tank. They interchange these tanks over and over, and they just keep refilling it, and then they send it back out. So this tank, it's not, you buy a brand new tank, usually with your torches, they give you a brand new set of tanks. First thing you got to do is exchange the new tanks for older tanks. And the tanks they give you sometimes aren't as good as the ones that you just bought. But they're empty, all right? And they don't fill them right there. It's not like a gas station. They send this stuff out to a chemical company like Air Gas or some other company that deals with the pressurized fluids, okay? So let me tell you a little bit about this thing. It's called a sleeping giant. It's kind of like a little palm. Now it's changed up a little bit from when I used it, but this is pretty much whatever it is inside. The whole thing's a compressed gas cylinder. So they say, get to know me. They contain very high pressure, very, very high pressure. They wear a label. So on the back you got a label. It says what it identifies with, what gas it's holding. In this case, it says nitrogen compressed. Color does not tell you what gas I contain. This thing could be blue, could be green. It used to be that they tried to use green for oxygen and red for acetylene, and then some other colors. But now a green tank, it could be argon, it could be nitrogen, it could be a bunch of different tanks. So you got to look at the label. They're only one piece of a two-part system. So this is one piece. This is the second piece to the two-part system right here. All right. Without a correct regulator or manifold, it cannot function safely. You got to know how to safely install and remove that regulator from the system. Make sure they're properly secured when it's stored or when in use. So this is secured right here. It's on a cart. Okay, it's just a small 9-inch base on this tank, and it is a little top heavy, especially once we put the regulator on. Underneath this cap, whenever we move it around, got to have the cap on, because underneath this cap is the main tank valve. So once you move it to the location that you need it in, then you can take the cap off and start with the procedure of putting on the regulator. But not until you get it to the location. And I like to try and keep it, if you notice, it's back up against between a couple pieces of furniture because I just don't want to get knocked over. I like to try and keep it up as close to the wall as possible. Now if it's in a room without the cart, then it's got to be strapped to the wall with a chain. And the cap's got to be on snug and tight. All right? And that's just because if this thing falls over, right, that regulator, the main valve, snaps off. This thing pops off with that valve open, or the main valve underneath here snaps off. There's just an opening no larger than the size of a lead pencil. And all that 2,500 pounds of pressure is going to take off. In fact, you see this being used as a weapon in some of the Hollywood movies, especially Arnold Schwarzenegger, man. He used these in like 2 or 3 of his movies. And how did he take out the bad guy? He tipped it over, smacked a hammer or an axe or something like that down with a valve, and it took off. And it would go through this 9-inch brick wall right here. It would make a nice little 9-inch hole, and it would shoot through this brick wall, the next brick wall, possibly even the far side outside the school, and maybe hit a couple other things before it decides to stop. And it won't stop until all the pressure is relieved. In fact, I got a story. In fact, when I was working, first started teaching, I went up to Air Gas to go get some stuff, and I was standing in line, and guy in front of me is like, I was talking to him a little bit, and he goes, "Oh, you're a teacher? I got a story for your kids." Well, he had a set of tanks like this with his dad. His dad was a welder, and they had oxyacetylene tanks for welding, and they usually strap them on the back of the pickup truck so that when they go to the job, they can, you know, just unroll the hoses and do whatever they need to do and roll it back up. Rarely do they take it off the truck to do any welding. They just pull the truck right up to whatever they got to do. But his dad was out of town one weekend, and he said some guy came up. This is back when this was farmland all around here, and came up to him and said, "Hey, knocked on the door. Is your dad around? I need some work. I need some work done." The guy was like, "No, my dad's out of town. But what do you need done? I've been working for my dad a while. I can probably handle it." He's like, "Well, yeah, I'll give you $500 if you can come over here and weld this piece of farm equipment for me." The guy's like, $500? Yeah, I'll do it. And he jumped in the truck and took off out of the barn. And when he took off going down the highway, he didn't notice that his dad didn't strap the tanks in when they changed them out. So what happened? Tank goes flying top over bottom into the street and came down and smacked the valve. He said he heard a and that was it. Looked up, lost sight of it. Couldn't see it. What do you think he did? Then he pulled that truck right back into the barn, shut the barn door, went back in the house, locked the door, and that was it. He was like, "Man, forget about that." Right? 18-year-old kid, 17-year-old kid. And about later that evening, about 4 or 5 hours, he said, went by. And later that evening, another knock at the door. Who do you think it was? No, not his dad. Dad was out of town. Dad didn't even know about it.
Police.
It was the police? Yeah, it was the police. Every single one of these tanks has a number on it. And they can track the number to see who registered the tank, who got the tank. You get registered. And they traced the tank back because they found it over in Alexandria. And when it decided to come back down, I mean, this thing went a mile up into the air. The guy in this is back in like the 70s, he said. There used to be in the 70s, going between Old Town Alexandria and up to Del Rey, a bridge that kind of had like an S curve. They've kind of changed it around a little bit. That bridge is no longer there. But he said the cops put him in the car and then drove him to the bridge there. And he got out of the car and he looked down at the bridge, and you know what he saw? A 9-inch hole right down there. But that isn't where it was. It was underneath. He goes down. The cops say, "Okay, get back in the car." Take him down to the bottom underneath the bridge and looks down in the ground, and it was buried about 10, 15 feet down in the ground. He said when it came down, it not only went through the bridge, but then went down into the ground like that there. So, I mean, these things are dangerous. So you got to be very careful with them. All right? It is just like a rocket or a missile if that valve snaps off. So when you're moving it around, you can't have the regulator on, cap's got to be on, and you got to be safe with it. No horseplay. There's no horseplay in here regularly anytime anyway. But no, just be mindful around this. You don't want to bump into it and knock it over. Okay, because it'll be out and about and around for people testing their projects. So it's been known to jet away faster than any dragster. It'll smash through brick walls. It will spin, ricochet, crash, splash through anything in its path. So it will scoff at the puny efforts of human flesh that try to alter my erratic course. So what does that mean, alter my erratic course? You don't know where it's going to go. That's right. It just goes anywhere, depending on the angle when that valve snaps off. So to be my master, remember, secure me, cap me, and always follow the recommended safety procedures and treat it with respect, because that is a sleeping giant right there. All right, so we're going to go ahead. I got a picture of a regulator valve up here. This is the thing that's going to be used to change the pressure from the tank pressure, what we got inside the tank of about 2,000, 2,500. When it starts to get empty, it goes down, 1,000, 500, 0. When the working pressure gauge says 0, that means we're out of gas. Got to change it out. And then there's another gauge off to the other side, and this is my working pressure. So my tank pressure, when that says 0, we're out of gas, it's done. Working pressure is controlled through this knob right here, which we got some parts. You got the whole piece is a regulator. But this is my tank valve, this is my working pressure valve, and this is my regulating valve. And on top of that, they have another valve here that we don't have that controls the flow. I'm using a Schrader valve. Then I got a main tank valve underneath here. Man, that's like 5 valves you got to remember. What was this? What I call that one? What? The main tank valve. This one, when you first get it, they tell you to crack it open. You hear that? That's a lot of pressure, yeah, in case there's any junk in there. Yeah, you heard that? That's what I'm talking about. That was just a quick little tss. They say to do that, but you got to have some goggles on, because if there's any metal flakes, they come out, to get in your, you can't do it without the goggles. Got to have the goggles on. So that's my main tank valve. So you got to make sure you won't do that for us. All right, we're just going to go ahead and hook it right up because it's been used several times. So we got, and then you see these things over here? See that here? That's this piece right here. That's a pressure relief device down in there. All right, that's a pressure relief. That's in case this thing gets hot. What would happen if this thing warmed up really, really hot, like in a fire or something like that? What would happen to the pressure? There's a relationship to pressure and temperature. It would go up. And eventually, if it can't leak out, it'll blow up. Tank will act like a bomb then. Your water heater could be something like that. There's a pressure relief valve on your water heater that whenever that pressure builds up, because let's say the heating element didn't shut off and just keeps heating the water, it boils it to 212 degrees and that pressure has nowhere to go. So there's supposed to be a relief valve almost on any pressurized vessel. So that's what this piece is right here. And it can't be installed in series. In other words, we can't install it in line. Pressure relief doesn't work like that. It's got to be parallel with the system. So this is my connection right here. This is a female connection. What we're going to be using is a male collar on this here. And the big thing with connecting this up is making sure that the threads do not cross from the male to the female side. They call that cross-threading. That's when it starts to turn in there a little bit and you catch maybe one or two threads, but it's not lined up the right way. And the threads they squeeze on top of each other because it's not lined up and it can strip the threads out. You should be able to screw this thing on by hand all the way to where you don't see any threads. And then after that, you can use, there's a cylinder wrench. I like to use, anybody remember the name of this wrench that almost closes all the way? It's not an open end, it's not a closed end, it's not a combination wrench. You better remember the name of this wrench from last week? What are you working with? What's your project, Justin? Hold your project up. What's he doing? Hold your project up. What is that project? Yep, that's the filter dryer. But what are we using to connect it up? What are those brass pieces on the end? Yeah, but what do we call them? Those are nuts. You got it. You're doing good. What do we call it when you make that 45-degree edge on the pipe? What are you doing? What's the practice project? What? Flaring. Yeah, you're flaring. So there's a flare. And then what type of wrench is that? This is just for those nuts. What was that? Flare nut wrench. Yeah, so this is a flare nut wrench. And the reason I like using this is because most guys just use an adjustable wrench, but we find that with the students, you round off the corners. You don't really tighten it up enough to get it. And then this way it gets around almost all 6 sides when you use the flare nut wrench. Okay, it's gripping all 6 sides. Less chance of stripping that nut out. Don't need to tighten really hard on this. Snug, again, we're going for that snug, and I'll show you how we do snug. So, okay, you're going to take off the cap. This is how you set it up for the nitrogen tank. 1, remove the cap. So let's put the steps up here. Remove the cap. 2, I'm going to connect the regulator. Now, if there was a brand new tank, that step of me opening and closing the valve real quick to blow out any debris would be in here, but I'm not mentioning that to you, although I just did. So we're going to connect the reg. Way back in the early 90s, there was this rapper called Warren G. He had a song out. It's called Regulator. You guys ever hear that one? No? Oh, I'll check that out on YouTube. That was a pretty good song. Started out with a nice little whistle. And I usually, if you forget the name, I'll whistle the tune to you so that you can remember it. Alright, so here we go. We're going to set it up. Got the cap off. We're going to connect the regulator. You're going to see me put the male collar of the nut into the female main valve portion here. And watch this. If it won't go all the way, I can wiggle it a little bit. But you got to be lined up. It can't be off like that. It's got to be completely lined up. Alright, it should be perpendicular to the tank. And then I can go ahead and screw it in by hand. Now, if I'm off a little bit or I let the weight of the regulator pull down on the nut, it makes it harder to turn. And you think you need a wrench already. But hey, just wiggle it around a little bit. Raise it up. Try and find that sweet spot where it goes straight in. And like I said, you shouldn't see any threads before you need the wrench. Alright, now if you notice, I turn this way. If I'm looking at the valve, everything's righty-tighty, lefty-loosey. So I'm going to go ahead and we're going to take this flare nut wrench and I'm going to face the valve, set it up here like this, and then pull down a little bit using my weight. Now I'm not going to hang on it, but I am going to use the weight to kind of pull down and get it snugged up. That's it. That's all I need. All right, and you notice I pulled the wrench. I didn't come back here and I didn't try and push the wrench. We never really push a wrench. Too much danger could happen with that. The thing could slip off, you could hit yourself, you bust your knuckles. There's a bunch of things that could go wrong if you try and push a wrench. And then for some of you that don't have a lot of strength, just use the leverage. Just drop down and pull into it a little bit. Now we got that all set up. It's connected. We've connected the regulator to the main valve. Now this is called our regulating valve right here. I'm going to back this out. This is to adjust my pressure. Now if I back it out too much, I continue to back it out all the way, eventually it'll fall out. And we can't turn this valve on with this regulator valve out because there's a little ball bearing in there. That ball bearing could shoot out if it pops the diaphragm. Talk about some other parts. So the pressure is going to come through here, and then it's pushing on this piece right here that's got a diaphragm and a spring and some other packing glands and another spring, a few other different things. But this is it right here, this diaphragm. This is what's controlling how much pressure comes from the tank out to the working area of our regulator down in here, the Schrader valve. All right, so if this is out all the way, the diaphragm doesn't have any tension on it. All right, and again, righty-tighty, you're gonna, if it comes out, screw it back in 2 times. You should see 1, 2, 3, 4, 5, 6 threads. So back out the regulating valve till you see 6 threads. Alright, and once you got that, then you can open the main valve. Back this out, make sure it's secure, and then we can open up the main valve. And when I open up the main valve, look at that, 2,500 pounds of pressure per square inch. Every inch that you see has got about 2,500 pounds of pressure behind it. Now on this gauge, there's like 3 different sets of readings. Okay, the outermost reading is 1 measurement, the innermost in the middle was red, and that's another measurement. We're looking all the way into the center for us. That's PSI. So when I look all the way to the center, the needle's pointing to 2,500. Over here, my working pressure, that's 0. Now this regulator can go up to about 500 PSI, which is 5 times the amount that we need for testing our projects. So I'm going to go ahead, we're just going to increase the regulating valve till it gets up to 100. Now no pressure is going to come out because I have a special valve in here that's going to block that pressure. It's called a Schrader valve. Same thing you use in bike tires, car tires, all right, it's a little Schrader valve. But I'm going to increase the pressure of this regulator up to 100 PSI. And once it gets to 100, all right, you can hear the pressure come out when I push it with my fingernail. All right? So you're going to set it to 100. I'm going to ask you, are you at 100? You say yes. I'm going to say back it down to 40. Let's say I didn't want you to do 100. Let's say I only wanted you to do 40. Well, now you got to back it out. But if you notice when I back it out, this needle doesn't drop. Because of the pressure that's built up back behind the valve, I kind of got to do 2 things at once. I got to push in the Schrader valve and adjust the pressure to what I want. And you can hear it kind of go down when I back this out. Till eventually nothing. All right, so we can adjust it, but you got to have, if you're adjusting it down, the Schrader valve depressed. Okay? So we're going to increase the pressure. You're going to turn the regulating valve clockwise. First, open the main valve on the tank. And then you can adjust the regulating valve to the set pressure. All right, and then that's it. You've connected up. You're ready to test to your project. Now, for your project, you're going to use one of these things here called a hose. Come in our refrigeration gauge manifold set. There's a few extra ones we have around. All right, but all we've done is we've taken one of the hoses off our set of gauges, and that's what you're going to use. And if you notice, on this particular, let me get the newer one. On this particular hose, it's got one end that goes straight, and then another end that has a 45-degree angle. This is for hooking up to our air conditioning units and having a little bit of room That's what this angle's for, because it's kind of hard when they go straight like these older ones did with the newer, well, the ones that have been made the last 20 years. But another thing that's different about these, other than the angle, the one with the angle's got a little piece in the center. That piece in the center is what depresses the Schrader valve so the pressure can come out the hose here. Now, Justin, you got your project ready. Let me see it real quick. So, Justin, is it all tightened up? Not really. 2 wrenches, 1 hand? No, I can feel it's loose a little bit. All right. So, let me ask you this. This one's got the valve. This one doesn't have anything in the center. Completely empty in the middle. There's nothing blocking it. Which one do you think I'm going to hook up to his project here? The what? The straight one or the angle? The straight one. Yeah, because that's the one. I'm going to do this first. Because if I hook this up first, what's going to be coming out of here? All the gas. And then it's going to be, you have to do it under pressure. That's a little hard. So hook this one up first here like this. Finger tight. You don't need a wrench for the connection to the hose, to the union. All right? We don't use wrenches. There's a little bit of a rough perforated edge on the outside of that for us to grip with our fingers to give it a tight grip. Same thing on this one. It's got some perforations on there. So then I can go ahead and I can hook it up to the nitrogen tank, and then I don't need anything more to test this. Why? Because I can hear the leak. That's right. It's leaking right here. Now look, don't put this stuff up to your face. Everybody wants to try and see if they can hear it with their ear. If the pressure blows out, or if something goes wrong with the flare nut, and all this pressure, 100 pounds, comes out next to your face, blow out your eardrum, it messes you up. You don't want, we use, for your project here, you're just going to stick it in a bucket. What do you hear? Bubbles, that's right. You got bubbles, that's a leak. That failed, that's a leak. That's bad. We can't have a leak. Can't lose the refrigerant. Now, in the real world, we don't use buckets of water because you can't take a whole AC unit and put it in the water. We get soap bubbles. Soap and bubbles. All right? So, now, once you test it, you notice I turned the main valve off? It all bled out. You don't have to do anything to the regulator. All right? Once you're done. Let it bleed out. Let it bleed out 0, 0. Then you go ahead and take the hose off. Now, the next person can't just turn this right back on. Why is that? There's a step missing. It's under pressure. I got pressure up against this diaphragm with the spring. If I turned it right back on real quick, some guys do. Some guys just come right back up and leave the regulator set and open it right up. You can pop that diaphragm. Yeah, I got all my pressure here again, but that diaphragm could blow in the center because it's just such a sudden force of pressure going through it that really, when you turn it off, and then you notice I turn it off, I can't take this regulator off yet because I got to bleed it out again. So if you don't have the hose hooked up, you got to bleed it out till it says 0, 0, and then you can take it off. But the next person should back out the regulator valve 6 threads. So you see 6 threads. So I'm going to go ahead and do it one more time without any interruptions here. I'm going to go ahead and set it up. Zero, 0. Now look, if you tightened it facing the regulator to loosen it, same thing. Get the flare nut wrench on it. Loosen it up. That's it. And then put the cap on, and the next person's going to go. Alright? So that's that. Now, I'm going to add a few more steps here, and those of you that came in late, you're going to have to write that stuff down, but let me go ahead and show you one full time real quick. 1, remove the cap. 2, connect the regulator valve to the main tank valve, making sure not to cross-thread the nut. If you notice that it doesn't tighten or it gets too tight after 1 or 2 threads, pull it back out. And again, you have a problem, wiggle it. Give it a little wiggle. Now that's not tight. Also, you notice I'm not facing the gauges down or too far up or anything. They're kind of like right in front of me where I can see the pressure. Grab the wrench, set it up, tighten it up. Next step, back out the regulating valve so I see how many threads. 6. 1, 2, 3, 4, 5, 6. Open up the main valve. adjust to your working pressure. In this case, it'll be 100 psi. And then connect your project up and put it in the bucket. Okay? Make sure you tighten it up with the wrenches, 2 wrenches, 1 hand before you do it, and then that's it. So now, once you get the adjust set to the pressure, to disassemble it, number 6, turn off the main valve once you're done. Alright, so now we got a different, this is the whole thing. So you're going to turn off the main valve, and then 7, bleed the pressure. In other words, you still have 2,500 pounds of pressure between this part of the regulator and the valve. You do not want to use a wrench, plus sometimes you can't even get it off. The pressure's built up too much, but normally if you do, it'll blow out, and it could be dangerous. So you got to bleed, turn off the main valve, bleed the pressure, and then you can, once you see 0, 0 on both gauges, 0, 0, then you can remove the regulator. Alright, so turn off the main valve, bleed the pressure, 0, 0. Once both gauges say 0, one of the needles is up, we're not 0, 0, something happened. And then you can remove the valve. You'll be doing this several times this year throughout the year for different projects. So it's a little scary at first, but once you get 2 or 3 times under your belt, you feel confident. If there's a period of time that goes by, let's say holiday break over the winter, 2 weeks, and you haven't done it for a while, and you need a recap on the procedure, let me know. Video will be on YouTube, so you can re-watch it. For those of you that came a little late, you're going to have to start off with the video on YouTube and do this little writing once I give you the paper. That's it. Everybody's got to get signed off on this today. Okay? So you're going to be getting signed off while you're working on your projects, and that's pretty much. Any questions?